This slide to say layers of the geosphere, because that's what it should say. Okay? What are they? Starting with the innermost center part of the geosphere. The core. And as we go away from the core, we head into the mantle and then the crust. Good. For composition, I'm going to give you the composition primarily of the core, primarily of the mantle, primarily of the crust. But all I want you to know for the test is iron, oxygen, magnesium, and silicone make up the majority of the, or those are the elements that are found most in the geosphere. Okay? So even though I'm going to give you the composition of each for the test, I only want you to know that these make up the geosphere. Okay? So let's learn about the core a little. We say C for core, C for center. Okay, that was bad. Underline this. C for center of the earth. Yes. So that you know it's the innermost part or center of the earth. And you want to know that it's subjected to extreme what? Heat or temperatures. Good. The inner core is solid and the outer core tends to be more liquid because it's getting towards that partially melted heat, right? And then you see this part, which you could go like that and just ignore. But you can never say I didn't tell you. M for mantle, M for middle, M for... One more M. What's going on there? What? I heard it. Yes, melting, good. Melted rock. So it's primarily rock. It's just melted rock, right? And again, we've got magnesium, iron, silicone. We're just going to go like that. All right? M for mantle, M for middle, M for magma. Remember that on the test. Then we've got the crust, which is the outermost part of the geosphere, which is made up of plates. What do we call these plates? Tectonic plates. And we're going to talk about those a little bit today. Because the three layers of the geosphere are core, mantle, and crust, I kept them in that order. But in between the mantle and the crust, so think about this. You've got the core, which is solid and then starts to become liquid because you've got liquid rock in the mantle, right? But that liquid rock is going to flow up. And as it once it hits the plates or the crust, it can't flow up, so it flows across and it forms like a river of magma, and that's called the asthenosphere. So the zone of hot melted rock that flows, or where magma flows like a river, is the asthenosphere. So look at this picture. You've got the mantle. You know, if I go further in is the core. Here's my crust, and then you've got this like flowing melted rock or flowing magma, which is the asthenosphere, okay? For years, I'm going to jump here for a minute, right here. The class was atmosphere, hydrosphere, lithosphere. And the reason is because the primaral, whatever, that's not even what I was going to say. The majority of topics that we're going to talk about involving the geosphere are going to happen in the lithosphere. So it's going to be a lot about what's going on in the mantle and then more about what's going on the surface, right? So the lithosphere makes up the upper mantle and crust. And if we're going to divide the crust into two parts, one is way bigger than the other. Anybody know what it's called? Like 70% of Earth bigger. What is 70% of Earth? Water. So we call it the oceanic crust, right? And then you've got the continental crust, which would be on the surface. But you know, hydrosphere has land, and the floor of the body of water is still the crust of Earth, which is the oceanic crust. So, anybody know why plates shift based on anything I just described about what's going on in our geosphere? Okay, the flow of the asthenosphere. So magma flows up, asthenosphere flows across. What happens when heat flows across? It cools, and when heat cools, it hardens, which applies pressure to the plate. So good. Magma rises, it flows across, it cools, it solidifies, applies pressure to these plates, causing shifts. And there's 3 types of shifts. Tectonic plates. Are we ready? So, when the plates shift, there's 3 different types of shifts that occur. Pick one, anybody. When plates come together, we call that convergent. When plates shift apart, divergent. And the last one is called transform. Nobody ever gets me that answer. I want you to pay attention to this, okay? Because your mind is going to choose the wrong answer. So convergent, put the word come together so you remember if you don't know. Divergent moves apart. Transform moves in parallel but opposite directions. Can this be transformed? Yeah. Yes, it does. It's either like this or like this, depending on which direction the plate lines are. When plates converge, which you see going like this, you would think it's going to do that, right? But it doesn't. When they converge, they form dips, which are trenches. When plates diverge, you would think that hole's going to, right? But when they diverge, they form the peaks or the ridges. I know. So keep that in mind. Think more. Converge makes more sense. I converge and I get a drop, right? And trenches form. When they diverge, somehow the land shifts up and forms those peaks, which are ridges or mountain ridges, okay? And then faults, which really make up all plate line boundaries, will not have any volcanic activity, will be the lowest of the damaging. So you have like an earthquake that will obviously change land, but these will transform lands, right? So convergent, divergent, transform lands.